We present a system that allows the user to interactively explore and visualize big visual data. The main inspiration of our work is the recent surge in the use of data analytics and visualization techniques in contemporary art. In particular, the simple technique of image averaging has been used extensively by several well-known visual media artists. For example, Jason Salvan created beautiful average images of special moments by manually aligning and averaging 100 images handpicked from the internet. But creating these averages requires a lot of time and manual effort. Here are example images downloaded from Google Images using the same search term, Kids with Santa. And here's the average image created by averaging the top 100 retrieved images. Notice how blurry the average looks compared to Jason Salvan's results. The reason for this is twofold. First, the returned Google images contain many diverse modes. For example, a kid could be sitting on Santa's left lap, right lap, or there could be two kids sitting on both laps. There are even images where a kid is wearing a Santa suit. And second, even the images that depict the same mode, like a kid sitting on Santa's left lap, are misaligned, which still results in a blurry average. Now, here are the average images created using our system, Average Explorer, on the same image collection. Below each mode, we display the top few images used to create the average and the feature correspondences between them. Notice how we're able to discover and align a diverse set of modes in the data. Here is our user interface. On the top left is the display for the average image, and on the top right will show the top retrieved images used to create the average image. We first demonstrate our coloring and sketching tools using a simple collection of 15,000 butterfly images downloaded from Google Image Search. Painting the wings blue gives it more weight in the average, and sketching the outline of the wing makes it sharper. Now we demonstrate our Explorer tool. It can be used to explore the different modes in the data computed by clustering small image regions from roughly the same spatial position across all images. At the bottom, we display the different modes found in the same spatial position. The user can toggle between them by pressing the Tab key on the keyboard. Okay, now let's explore what's in the data. For Kids with Santa, one natural question is, what are the other modes besides the one that Jason Salvan found? Here we show how the average image progressively updates with each user edit to create a sharp average image in which Santa has two kids sitting on both of his laps. Now, everybody knows that the internet is full of cats. But what does the average internet cat look like? Starting with a simple average that looks gray, we can use our Explorer tool to interactively reweight and align the images. We can first click on the nose, the eyes, and then the ears. Notice how with each user edit, the average gets sharper and sharper. Here's the result with and without alignment. We can even align cats of various breeds. Notice how sharp each of the cat faces become. Now, let's explore what's in Paris. Obviously, there are lots and lots of images of the Eiffel Tower, which may not be so interesting. But hold on, since our average image is progressively updated, if we change the color of the sky to black, we can reveal a mode of the Eiffel Tower at nighttime. In this example, we demonstrate how we can simultaneously edit multiple clusters. Here we have 6 clusters created from a large face database. Notice how an edit on the current average image propagates to the other clusters, making each of their average images sharper in their respective regions. On the top right, you can see the automatically found correspondences between the top retrieved images for each respective cluster. Here's a fun application of our system. It could be used to generate interactive portraits on social networking websites. The idea is that a visitor could interactively explore the user's personal photo collection. For example, we could explore the different facial expressions and poses of our friend Jane Doe, and once we like what we find, we can make her portrait sharper by clicking on her facial key points. We can also see what her average face looked like when she was wearing a pink shirt. Since our system accurately aligns images, we can efficiently annotate key points for a large face database by annotating just the average images, and then automatically propagate the annotations to their cluster instances. We can even annotate objects for which there are no existing algorithms for automatic alignment. For example, just with a few clicks, we can annotate various parts of cars, allowing us to morph from one car to the other. Our system can also be used for online shopping. Suppose you're looking for shoes. The color seems a bit boring, so let's make it more exciting with red. Now, let's search for shoes of similar style and color, but with more stability. Finally, our system can be used for visual analytics, which is the discovery and communication of meaningful potentially hidden patterns in the data. Given a large collection of the Colbert Report footage, we can discover what ties Stephen Colbert likes to wear by first fixing the region of interest on his face and then exploring the region beneath it.